Hi and welcome to a new section, introducing TypeScript. This section is not a thorough overview of the TypeScript language. We'll just focus on the core elements of the language and study them in detail on our journey through Angular. The good news is that TypeScript is not all that complex, and we'll manage to cover most of its relevant parts. Let's start with the first video, Types in TypeScript. Now, to get support in learning and test driving our new knowledge of TypeScript, our first stop is the official site for the language. Let's enter the URL www.typescriptlang.org. Here you can find a more extensive introduction to the language and links to IDEs and corporate supporters of this project. Nevertheless, the most important sections that we will definitely revisit more often are the Learn section and the Play sandbox. Click on Quick Starts in the Learn section. This gives us access to a quick tutorial to get up to speed with the language in no time. It might be interesting as to recap on what we discussed in the previous section, but we would suggest you skip it in favour of the sample pages and the language spec. So you can click on Docs and browse the tutorials. Now, the GitHub link is a direct link to the full extensive documentation of the language at GitHub. This is a priceless resource for both new and experienced users. The code for TypeScript is fully open sourced at GitHub, and the Microsoft team has made a good effort at documenting the different facets of the code in the wiki available on the repository site. We encourage you to go take a look at it any time you have a question or want to delve deeper into any of the language features or form aspects of its syntax. Also, we have the Play section, which offers a convenient sandbox including some ready-made code examples, covering some of the most common traits of the language. We encourage you to leverage this tool to test out the code examples we'll see throughout this section. Now, before we proceed, let's refresh our knowledge about types. So, types is a noun used to represent the fact that the data used can be a text string, an integer value, or an array of these value types, among others. This is nothing new to JavaScript, since we've always been working implicitly with types, but in a flexible manner. This means that any given variable could assume or return any type of value. Sometimes this leads to errors and exceptions in our code because of type collisions between what our code returned and what we expected it to return type-wise. While this flexibility can still be enforced by means of any type that we'll see later on in this section, statically typing our variables gives us and our IDEs a good picture of what kind of data we're supposed to find on each instance of code. This becomes an invaluable way to help debug our applications at compile time before it's too late. The first type we'll discuss here is string, which is probably one of the most widely used primitive types in our code, and where we populate a variable with a piece of text. For instance, here's an example on your screen. In string type, we can use either single or double quotes, and it's the same as ECMAScript 6. We can define multi-line text string with support for text interpolation with placeholder variables by using the same type. Here's a sample code to help you understand how it works. We declare the variable as string using the string keyword. Check out the type assignation next to the variable name, which is separated by a colon symbol. This is how we annotate types in TypeScript. We use either single or double quotes. TypeScript, as a subset of ECMAScript 6, supports expressive declaration nouns such as let, which informs us that the variable is scoped to the nearest enclosing block, which is either a function for loop or any enclosing statement. On the other hand, const is an indicator that the values declared this way are always meant to feature the same type or value once populated. For the rest of this section, we'll enforce the traditional var notation for declaring variables, but do remember to use let and const where appropriate. In a lot of cases in the code, I've been using var to declare objects, variables, and other constructs. It's really discouraged when starting with ES6 or TypeScript. There's a reason for that, and it's because EC5 only have method scope. For most developers coming from another language and starting to use JavaScript, this comes as a bit of a shock. So firstly, what do we mean with function scope? We mean that a variable is unique within the context of a function. For example, have a look at this piece of code. Here we've declared a variable, a, and it's unique in the scope of that function test. There can be no other variable a in that function. If you do declare more of it, then you will effectively redefine it. Okay, so that's good, but when is the scoping not there? It's not there in for loops. For example, in Java, you would write something similar to this. In Java, you would know that the variable I would never leak outside of the for loop, and you could write even like this, and know that the variable I outside of the for loop would not affect the variable I inside the for loop. They would be separated or scoped, as it is called. OK, so users of ES5 JavaScript have had this language flaw for a long time, and recently a fix for this has been added to ES6 and TypeScript respectively, namely the let keyword. So, to use it, let me show you an example. The reason this works is that the TypeScript compiler translates this to the ES5 code. Wait, I'll show you how the translated ES5 code looks like. You could the error for the variable because we're having multiple declaration. The compiler essentially renames the variable within the for loop so that a name collision doesn't happen. So remember, no more var. Just use the let keyword when in doubt. The next is the const keyword, which is a way for you to convey that this data should never be changed. As a code base grows, it's easy that changes happen by mistake. Such a mistake might be costly. To get compile time support for this, the const keyword is there to help you. Look at the second line in this block of code. Such a declaration is not allowed. If you compile this code, it will throw an error stating that cannot assign to PI because it's a constant or a read-only property. A word of caution here. This works only on the top level. You need to be aware of this if you declare objects as const. For instance, look at this piece of code. Declaring the obj const does not freeze the entire object from being edited, but rather what obj points to. So, this form of code would not be allowed. Here we actively change what obj points to, not one of its child properties. Therefore, it's not allowed, and you get the same compiler error as before. Now let's talk about number. Number is probably the other most widespread primitive data type, along with string and boolean. The same as in JavaScript, number defines a floating point number. The number type also defines hexadecimal, decimal, binary, and octal literals. Here's an example demonstrating the use of number data type. Similarly, the boolean type defines data that can be true or false, representing the fulfillment of a condition. Another widely used data type is the array. Here we've defined a simple array. Assigning wrong member types to arrays and handling exceptions that arise by that can now be easily avoided with the array type, where we describe an array containing certain types only. The syntax just requires the postfix in the type annotation. If we try to add a new member to the children ages array with a type other than number, the runtime type checker will complain, making sure our typed members remain consistent and our code is error-free. Sometimes it's hard to infer the data type out of the information we have at some point, especially when we're porting legacy code to TypeScript or integrating loosely typed third-party libraries and modules. Don't worry, TypeScript supplies us with a convenient type for these cases. Here's an example demonstrating its use. So, the any type is compatible with all the other existing types, so we can type any data value with it and assign any value to it later on. This great power comes with great responsibility though. If we bypass the convenience of static type checking, we're opening the door to type errors when piping data through our modules, and it will be up to us to ensure type safety throughout our application. For instance, have a look at this block of code. The null and undefined JavaScript literals require special mention. In a nutshell, they are typed under the any type. This makes it possible later on to assign these literals to any other variable, regardless of its original type. Let's talk about the custom type. In TypeScript, you're able to come up with your own type if you need to by using the type keyword in this way. What we've created now is a type with X number of allowed values. Let's create a variable from this type. This is perfectly allowed as cheetah is one of the allowed values and works as intended. The interesting part happens when we give our variable a value it does not expect. For example, we change it to turtle. This results in a compiler error stating that it's not an assignable type. The next type is Enum, which is basically a set of unique numeric values that we can represent by assigning friendly names to each of them. The use of enums goes beyond assigning an alias to a number. We can use them as a way to list, in a convenient and recognizable way, the different variations that a specific type can assume. Enums are declared using the enum keyword, without var or any other variable declaration noun, and they begin numbering members starting at 0, unless explicit numeric values are assigned to them. Inspecting the value of my car will return 1, which is the index held by Cadillac in the enum. As we mentioned already, we can assign custom numeric values in the enum. So let's click on Run and check the value for my car. You can see that it's the same expected output. Let's see another example. Inspecting my truck will yield 2, since the first enumerated value was set as 1 already. We can extend value assignation to all the enum members, as long as such values are integers. One last trick worth mentioning is the possibility to look up the enum member mapped to a given numeric value. Here's a simple example for that. It should be mentioned that from TypeScript 2.4 it's possible to assign string values to enums. We've mapped the enum number to one which refers to Cadillac. So let's go ahead and check what we get on executing my car brand name. We have more crucial data types, that is void. The void type definitely represents the absence of any type, and its use is constrained to annotating functions that do not return an actual value. Therefore, there is no return type either. We already had the chance to see this with an actual example in the previous section. For instance, have a look at this piece of code. Here, the keyword void represents the absence of any type. Now, typing our data is optional since TypeScript is smart enough to infer the data type of our variables and function return values out of context with a certain level of accuracy. When no type inference is possible, TypeScript will assign the dynamic anyType to the loosely typed data at the cost of reducing type checking to a bare minimum. An example of inferring at work can be seen in this code. This holds the same effect, that is, it will lead to a compilation error if you try to assign a non-compatible data type to it. So, if you add this code, it throws a compilation error. That means, since we have declared brands as a string data type, we cannot assign it a boolean or an integer value.